power factor correction system. As you know, in this recent power condition, power factor correction is really really need a lot. So usually what we done in the industries, like most of the countries, most of the states have already gained penalties on lagging power factor. So accordingly our project will satisfy the need. So accordingly you may have the advantages like reduced bills on the electricity charges and reduced prices and everything. So here is our system. To explaining the better system, this is our main MCB where we are getting the supply. Okay, this is the supply. This is the load terminal. On this terminal you have to give the motor's main load terminals, and overall you can see this is the multifunction meter which will usually measure kilowatt, kVAR, power factor and all the related parameters. Along with this, we have this APFC controller, which is ETA controller from the Lawrence Knudsen company, previously known as L&T. So usually it will show all the alarms, protection which are required, and other than the steps required. And for the input parameter setting, we have to set the capacitor voltage, capacitor ratings, overcompensation range, undercompensation range, and all the parameters which are needed, which will guide you in the next video. So accordingly, we have used these MCBs. These are the Mitsubishi based. So this one 3-phase supply. So 3-phase supply will go into MCB. It will charge the contactor. Contactor C5. C5 is a 5 ampere MOC5, which will provide power to a 1 kVAR capacitor. So total 3 kVAR capacitor bank is installed in our system. So accordingly, the capacitor, we have individual MCB for the protections. So here you have the 3 auto and manual switch. One position is auto. If you put it in center, it will be off. Second is manual mode. So manually you can also adjust the automatic the power factor correction system. If you see this is the lamps, this is the ammeter and the voltmeter. On this TV there are control TV as well as the power TV. As well as the UM1, UM2 will feed the power to APFC controller. And this is S1, S2 of the CT, which is coming incoming line. So accordingly, whatever APFC controller will do, it will measure the voltage as well current cosine angle, and accordingly it will let the capacitor on automatically as per the requirement of the system. And if it feels like just the PF is still lag like 0.7, 0.75, so we have set the range to 0.95. In first step, it will, suppose if we calculate 0.6, it will make to 0.75. If still it is lag, then it will start another capacitor in on condition, so that automatically reactive power will improve. So this is the overall functioning of our system, and we would like to thank our faculty of the LD College of Engineering, all the sirs which have guided us, and without their support it was not possible for us to complete this project within time, and we would really congratulate all the professors for helping us out. Thank you very much.